So let's get started on inheritance, and we're going to apply it right here. So in this case, I'm going to do all my code inside the same file, but normally every class you would put it in a different file. So just be warned that we're doing that. So we're going to keep this superclass by itself, and what we're going to do is we're going to create a new class, and let's call it student. And then we got to think about what a student is defined by, right? What is the attributes of our student? So let's make a couple attributes. I'm going to make them all public for now. So a student, they would have let's say a first name. They would have a last name. They would have something more specific to a student. They would have a ID, let's say. So they have a student ID. Maybe they have an amount that they owe. So let's say the dues, how much they owe to the school, let's say, dues to school. Or you could name it however you want. So these are some attributes and some actions that it could do. It could be such as public, void, and let's say study. And we could give it a time and maybe a subject, right? And inside of that, we'll just do something simple, nothing too crazy. So we're going to say first name, studying, and we're going to add subject, and we're going to say for this much time, okay? So for time, and let's keep it short. Let's not go further. Right, this is a normal class student that we would have, and normally when we create a student, well, we need to initialize at least these three variables. The dues to school, that could be accumulated over time or reduced, but whenever we create a student, we need for sure to make to assign the value for first name, last name, and let's say again the ID. But in this case, the ID is specific to students, so we're gonna assign it ourselves. I don't want to get into too much details, but I feel like if I skip some parts, you're going to be confused. And in this case, we're gonna just think about it. We're going to go off a little bit before we start the extend. We're building our student class. For the first name and last name is pretty straightforward. Whatever that's given to us, we're going to assign it, right? But for the ID, we can't let the constructor decide. We can't let the caller, so let's say over here, let's do two cases. So we're going to create an int ID here, and we're going to assign it just to see how it does or how it works. So the problem with allowing outsiders to assign it, we would get something like this. Student A equals new student, and in here, control P, we need to give it an ID, a first name, and a last name. So I'm going to give the ID 1, and let's say ASD for the first name and whatever for the last name. Let's make it something different. Or let's make it Smith and John, right? So John Smith is our first student at ID 1. But if I want to create another student, let's call it student B. We got to again give an ID, and let's give it a name. So this one is Jane and Jones, I don't know, something like this. Jane Jonas. But notice that ID is still 1, and there is no compiler issue. So if I run these both, it works out perfectly because there is no issue ongoing because I respected all the rules for that student, right? No compiler issue, and we could print it, do whatever. We could say a dot, let's say study. We're going to give it a time, 23, and a subject, algebra. And we'll do the same thing for B. It's going to study, time 12, and let's say something else, history. Right, and now we'll get some outputs to the screen. Right, John is studying algebra for 23, Jane is studying history for 12. It's perfectly fine. But the problem is with the ID being both the same, it becomes problematic, especially if both students are named the same thing, right? John and John, maybe. So to not make these mistakes, schools don't allow outsiders to specify the ID. The ID is being assigned by the school. So we could do the same thing with our class here. So rather than assigning this value, allowing outsiders to assign it, we're going to remove it and we're going to assign it ourselves. But how can we assign it ourselves? If I put 1 here, well, then they're back to both having the same ID again, right? I can't put 1 here and then increase it. We don't know. Well, to be able to do this, we're just going to do a static variable. Again, we're going to just keep everything public for now. So we're going to make something static. So it belongs to the class. So all students will have kind of an access to it. Actually, we could make it private directly. And what we're going to do is we're going to specify a value. So in this case, current student, let's say, and we start off with 0. And whenever we're creating an object of student, we set the ID to the current student, and then we increase the current student to ++. So if I wanted to print out the IDs, let's say printing out here a.id, and then we do b.id, you'll notice that it's going to work correctly because the ID is going to get increased and it's a shared variable. So every student has access to this, right? They could all change it and so forth, so on. So anyway, getting off point. Coming back to our student. Our student is pretty much straightforward, done, and so forth, so on. But then we also have another class called teacher. All right, and what does a teacher have? Well, they also have a first name. They also have a last name. They also have other stuff. Now, yes, a teacher has an ID, but we're going to skip that. What other things could, well, actually, we're going to make an ID. And again, this ID will need to have it statically given to us. So we're going to do the same thing here. But this time, it's not the current student, it's the current teacher. The IDs have to be different, right? Because this one is adding a new ID for every student. So there is a possibility that a student and a teacher has the same ID. Let's say 5, and they're both number 5. And a teacher, what could a teacher do? A teacher could teach, and they could teach a specific student. Maybe we could add that. So, and we add a student here. And we could even say a subject, maybe. Subject. Nothing too intense. And again, we're just going to print out. So first name is teaching, subject to, and here we do student dot first name. Cool. So now if I create a new teacher, and let's call it T for the teacher, new teacher, we forgot to put the first name, last name. So we're going to create a constructor, kind of the same thing as student over here. We're just going to change some values. This is teacher, and this is current teacher, and the first name, last name. Okay. So again, if I'm going too fast, just pause it so we don't make this video too long. I'm going to be the teacher here. So in this case, we created a teacher. And after all of that, we're just going to say T dot teach. Which student do we want to teach? We're going to teach the student A. And what subject we're going to teach? Let's say program. Right? And now if we run it, our application still functions correctly. So Reza is teaching programming to John. Cool. Everything's working out fine. Now, the problem with our code is it's a lot of repetition, a lot of stuff that was not needed, or you could see it's being repeated. What happens if ever your boss comes and tells you to change something, or to change, let's say, I don't want to have any more first name, last name. I want you to go combine them. Well, you have to go here, erase both of these and put them together. But then you have to also go to teacher erase them and put them together, right? We're creating more places that I have to update and I have to memorize and remember. What if we had more than just student and teacher? Student, teacher, janitor, administration, principal, student counseling, etc. And we're coming down to like 10 classes that all take first name, last name, and whatever else that is there. So here comes inheritance. It would allow us to, this repetition of code, we're going to merge them together into one place and inherit those variables like we would do in the real world. We would inherit from our parents and so forth, so on. So the only thing we have to specify is from who are these student and teacher going to inherit? Well, the what we know. It's the first name and last name that are really unique. The ID is they both have it, but this is more unique to student and teacher. While the first name and last name is something that all of them have, right? So we could say a student is a person. A teacher is a person. So we could create a class called person. And inside of that, we know that it has a first name and last name. All person do, right? And we could also create a constructor saying, when we create a person, you need to make sure that you give me the first name and the last name. Oops, I pressed the wrong button. All right, and all I'm going to do is say this first name equals first name and this dot last name equals last name. Nothing too fancy, nothing crazy, but now I brought those two attributes up here to person. And now what I could do is inherit. So we're going to utilize the keyword extend. So student is a person. A student extends the person class. And because I extend it, student now has all attributes and all methods, so all actions that a person would have. So we could say now we don't need to have a first name, last name, and this would work, right? Now, we're going to come back to teacher in a second. You'll notice that my constructor is also having a difficulty. This is the second part, is for us to have a student, we first need to have a person. So the constructor of student is perfect, but you need to respect the rule of person. So the construction rule. So inside student, we need to create a person. We're going to talk about this keyword, but this is called the super keyword, which basically means the class you inherited from, the base class, the super class. And you could see here, the moment I'm doing this, the first line, you could see here, the moment I do the parentheses, it's asking for first name and last name. So we could just forward it to our parent constructor, our super constructor. And before we go forward, I just want to draw you a little memory thing. It's basically the chicken and the egg, but we're just going to do a quick thing here. So this is again our stack. And we could again do a heap. And again, we're doing this really quick. And over time, we're going to see this. We're going to evolve it more and more. So here, if I create a student, so let's scroll up one second. When I create student A, line 5, we have to create a student. But for a student to be able to get created, we first have to create the parent, right? Before you were born, your parent had to exist. If they didn't exist, you cannot exist. It's something like that. So for us to be able to create a student object, we first need to create a person object. So our object is actually two things together, and this is going to reference both of them. Well, to be in reality, we would reference the student, which has the person connected to it. It becomes one object. We're going to leave it at that. In the case of a teacher, though, we haven't done inheritance yet. We didn't extend. So when we create a teacher, T, over here at line 7, it's just going to go look for enough space to create the object teacher. Okay, so for us to extend teacher, well, then we need to include a person part to it. Let's scroll down here. We're going to come back to that in a second. But notice now, our student is not done yet. Because we call the parent constructor, and you could see here, they're already doing first name equals first name, the field first name equals the parameter first name. Then we don't need to do this inside our student. Right? And now if you look, our student class is more specific to it's more specific to what a student does and not a person. So over here, person still has the first name and any other action, but our student is only dealing with the IDs, the dues to school, and the studying. Right? Do we still have access from student, the first name, last name? Obviously. So if we look at these two values, let's run it. You could still see that we get the first name. When we say study, we get the first name, right? And we show studying. When a teacher teaches programming to student A, you could see here, Reza is teaching programming to John. That's the student. So it's perfectly fine, but now it's more focused, while person will take care of that. And because teacher also does the same thing, we could do the same thing by saying extends person. Over here, we're going to do super and Control P. We need the first name and last name to call the constructor of my parent. Constructor, parent, constructor. We're going to do another video on super and we'll talk about it further, but this is fine. And again, we don't need this. We don't need these parameters. They're already defined inside person. And you could see that I still have access to first name, even though we don't have any field called first name. And again, our teacher class becomes more specific to what a teacher does and not what a person does. Again, remember that we inherit everything from the parent class. That's not only the fields, but it could also be a method such as talk. Let's say over here, message. And what we do inside is basically say first name says, let's say that plus message. And I forgot the plus over here. Right? So now this method that's only defined in person will have access to it from any of these three. Right? We defined one method that's accessible by two different types of objects and by three different objects. So here we'll just put it at the end. So let's say a dot talks. I don't know. Let's say rar. Let's just make it short. Talk, meow, and lastly, teacher dot talk. Woof. So you can see that all three have that method that we define in person. Let's actually go see structure. So you could see that this method that's been defined in person is also available to us in student and in teacher because they inherit all the methods and fields variable that's possible. So if we run this, you could see that we get roar, meow, and woof. It works perfectly fine, right? Even though you could see that there is no talk inside student or teacher, right? These are our class. There's two methods, two fields. Same thing goes with the student and the teacher. Two methods, three different fields, but it also inherited these two fields and these two methods. Well, the constructor is not inherited, but called. Cool? And this is how inheritance work with this keyword called extends. It enables us to either make a program much less boilerplate, like all the duplicate code is in one place. It makes it more specific to what its task is. So a student will only have the code for student. So the modularity is much better. And lastly, something we might come back to is it would allow us to extend a object's functionalities, to give it more functionalities than it originally has, right? Because we still get all the default functionality. Cool. I'll see you guys in the next video.